I'm back. Sorry, this is incredibly difficult because he just wants his mama. So I'm sorry, guys. All right, here we go. So we're going to, first rule of dividing fractions, keep the first the same, change to multiplication, and take the reciprocal of the right-hand side. All right, and now we're going to follow the same directions because we're going to factor if possible in the numerator. Well, notice it's a monomial. There's nothing we can factor out, so I'm just going to write it as 8 times 14 times x squared. Just write it out, why not? And then on the right-hand side, this does have a greatest common factor of 2. Okay, so I'm going to factor this to be 2 times 2x plus 1. So now in the denominator, I have 21 times 2 times x to the third times 2x plus 1. All right, canceling out. We know that 2 and 8 have a greatest common factor of 2, so that becomes a 1, that becomes a 4. 21 and 14 have a greatest common factor of 7, so that becomes a 2, that becomes a 3. How many x's do I have in the numerator? Let's see, I've got 1, 2, 3. Oh, sweet. So those can all cancel. And now we just multiply across. So in the numerator, I have 4 times 2 times 1, so I have 8. And in the denominator, 3 times 1 times this quantity. So we have 3 times 2x plus 1. And there's no need to multiply that out. You can leave it as is. Sweet. Nice job, guys. All right, on the right-hand side, here we go. We keep the same for the first fraction. We change it to multiplication, and then we flip the right-hand side. We take the reciprocal. And then we factor if we can. Now, on the left, it's already factored out. They don't have any greatest common factors. On the right, what multiplies to 8 and adds to 6, I can immediately factor that as x plus 4 and x plus 2. But in the denominator, it has a leading coefficient of 3. So we're going to have to factor using the x factor. So what multiplies to 6 and adds to 5? 3 and 2. So then 3x squared plus 3x plus 2x plus 2. Factor by grouping. Greatest common factor is 3x, and we get x plus 1. Greatest common factor is 2. We get x plus 1. Pull out the x plus 1s. Group what's left together. Pardon my sniffles. All right, so then in the denominator, we have x plus 1 and 3x plus 2. Okay, we are looking for identical pieces, yeah? Identical pieces. So I have an x plus 4. Shoot, and that's it, I think. All right, so final answer. X plus 5 times x plus 2 all over x plus 1 times 3x plus 2. Ta-da! All right, guys, last one. It looks stranger and crazier than it truly is. Group the top, group the bottom. All it is a fraction being divided by a fraction. Okay, so I'm going to write it out. I'm going to write it out as x squared minus 4 over x plus 3 being divided by x squared minus 4x plus 4 all over x squared plus 3x. In writing it out, it becomes a heck of a lot more manageable. Okay, so group it, write it out, and then do what we've been doing on the last two problems. Keep the first, change to multiplication, flip or take the reciprocal of the right-hand side. Didn't know it was so easy, did ya? Okay, factor. So on the left, difference of squares, we have x plus 2 times x minus 2 all over x plus 3, because x and 3 don't have a greatest common factor other than 1. On the right-hand side, the numerator's GCF is x, so x times x plus 3. In the denominator, what multiplies to a positive 4 adds to a negative 4. We get x minus 2 times x minus 2. Look for identical pieces. X plus 3, x minus 2, x plus 2. What? What's left over? just x. So our final answer is x. Right on. All right, guys, I hope you have a great day, and I hope to see you tomorrow. Bye.